The best way to approach these is probably to just plug in a number that fits the requirements. And these are not just random. It's because if I plug in 5 for x, I would get 5 minus 5 as 0. If I plug in 6, I would get 6 minus 5 as 1, which is positive. If I plug in 4, or any number smaller than 5, then this piece would end up being negative. So we have to see what happens when we plug in a number from 5 to infinity. So if I plug in like 6, for example, 6 minus 5 over 5 times any negative number. We can just pick negative 1. So that's going to be negative 1 over negative 5, which is positive. So we can say that under these requirements, part A, okay, that would produce a positive slope. Slope is positive. Because it's not relevant that we pick 6, we just had to pick a number that falls between 5 and infinity. So any number between 5 and infinity is going to produce this being positive, multiplied by a negative, and then divided by another negative, which ultimately is going to be positive. So now instead of going 5 to infinity, let's go the other part of the number line, negative infinity to 5. So I can just, pick 4. It doesn't matter which number I pick, but it seems like a natural choice. And then y is still negative, so we'll just keep that as being negative 1. So that's going to give us negative 1 over negative 5, which is going to be positive 1 over negative 5, which is negative. So in this case, we'll have a slope that is negative. And then last, we have 5 to infinity, but y is positive. We don't have to redo work here. 5 to infinity is just going to be the case here where we had like 6 minus 5. But now we're just going to make y positive instead of negative. So let's flip this negative 1 to make it positive. That's going to make this positive, which is going to make the overall result negative. So under these conditions, the slope is negative. And that's it. You can always just mess with the different intervals, plug in values that fit those intervals, and then determine, is that producing a positive or negative slope.